Good morning, dear student. In today's lecture, we are very much interested in the important points regarding to the diffusion, that is mechanism of diffusion. So, the vibrational energy of atoms is the main source that initiate the jumping of the atoms. So, if you consider whenever we study the diffusion, then the vibrational energy of atoms is responsible. So vibrational energy of atoms source is the main source that initiate the jumping of atoms, that initiate the jumping of the atoms. Okay, a single jump by the diffusing atom is known as unit step. The second important point is that, so you should remember this point. So the vibrational energy of atoms is the main source that initiate the jumping of the atoms. Again, a single jump by the diffusing atom is known as unit step is known as unit step. And the several mechanisms are known to causes atomic diffusions. So let's discuss one by one. The first one, that is the vacancy diffusion. Vacancy diffusion. If there is any vacancy. So if you consider what is vacancy diffusion, let us see the diagrams. That is the solid, it is made up of by the atoms. Okay, then if you consider this solid, and this is the vacancy, and the movement of these atoms from their original place to the vacant site, it is called vacancy diffusion. So you observe, so there is a vacancy in the material or in the solids. So what is about let us consider this vacancy diffusion, and let us consider the important points regarding to this vacancy diffusion. We already know that vacancies are the vacant atomic sites. So what is this vacancy? Vacancy is nothing but the vacant or empty atomic sites. Vacancy is nothing but your vacant atomic sites or empty sites. Vacancy is nothing but your vacant atomic sites. Vacancy diffusion occur if the atom interchange their position with the surrounding vacant site. So vacancy diffusion is occur when the atoms interchange their position with surrounding vacant site. So if you consider this is a vacant site, in this case this is a vacant site, and the atoms, okay, which is close to this vacant site, interchange their position with this vacant site, then such a type of diffusion is called vacancy diffusion. That is whatever the vacant site, it is known as atomic whatever the vacancies, it is known as vacant atomic sites, so empty atomic sites. And the diffusion occur if the atoms interchange their position. If the diffusion is occur only when the atoms interchange their position with surrounding vacant site. When these atoms occupy the vacant site, another set of vacant site is created at initial location of this atom. So what happens when these atoms get diffused from from their original place to this vacant site, then the vacancy is created. That is the another set of vacant site is created at initial location of their atoms. at the initial location. So we can write this as like this. Then there is the vacancy, and it look like this. So the atoms get shift. So in this case here there is a vacancy, so we get this. So the vacancy is created in this, like in this fashion. It is called vacancy diffusion. So whatever the vacancies are nothing but the vacant atomic sites. Vacancy diffusion occur if the atoms interchange their position with surrounding vacant site. When these atoms occupy the vacant site, another set of vacant site is created at initial location of these atoms. Okay. If you consider this vacancy diffusion, it is responsible for the phenomena uh, which is known as crips in the materials. That is, it is responsible for crips, CREAP, crips in material. Cracks in material. So that is, it is responsible for different cracks in the materials. Whatever the vacancy is there, it is responsible for the cracking in the materials. Okay. So again, if you consider this vacancy diffusion, it is the process of self diffusion, and it is occur in gold and silver. For example, it is a self diffusion. It is a type of self diffusion, that is, atom itself diffuse from its original place to the another place. And the example is the self diffusion with gold and silver. Okay, example is gold and silver, that is silver, that is Ag and Au, silver and gold. Okay, self diffusion. So you should remember what is vacancy diffusion. That is, atoms interchange their position with surrounding vacant site. When these atoms occupy the vacant site, another sets of vacant site is created at initial location of these atoms. Okay, and this vacancy diffusion is responsible for different types of cracks in the material. It is a bulk diffusion process. Again, this vacancy diffusion, it is a bulk diffusion process, and it is a process of cell diffusion in silver and gold. So let us consider the second types of diffusion, that is interstitial mechanism or interstitial diffusion. So this is your vacancy diffusion. Let us discuss the second type of mechanism, that is interstitial mechanism. Interstitial mechanism or interstitial diffusion. So what is this interstitial diffusion? The atoms which are very small, the atoms which are very small, the atoms which are very small enough to occupy the interstitial sites, the interstitial site. So the size of the atom is very small, so it occupy the interstitial position or interstitial sites, and diffuse by jumping from one interstitial sites one interstitial sites site to another. So let us discuss the diagram. That is, if you consider these are the atoms, then if you consider this is the atom, so the small circle, this is the atoms present at interstitial sites. Okay, so small void is there between these four atoms, and it is called interstitial position. So the atom due to its very small size, it is placed in this interstitial position, and it will jump from this one interstitial sites to this another interstitial sites, it is called interstitial mechanism. That is, okay, from one interstitial site to another interstitial site, and it is considered as a unit step. That is, it diffuses by jumping from one interstitial sites to another interstitial sites. It is called the interstitial mechanism. The interstitial atoms has to overcome the potential energy barrier. So when it is jump from these sites and passes and goes to this interstitial site, it will overcome the potential energy barrier of this parent atoms, and therefore if you consider, we can write, that is, you should remember that what is interstitial diffusion. So whatever the sites or the vacant site is present between these four atoms is called interstitial site, and some atoms are very small, so they occupy these sites, and there is a jumping of these small atoms from this one interstitial site to the another interstitial site. It is called interstitial diffusion. And if you consider the next important points regarding to this interstitial diffusion is that the interstitial atom has to overcome the potential energy barrier. It is denoted by symbol HM, capital HM, potential energy barrier, to push through the parent atom, the parent atom. And this potential energy barrier, it is also known as enthalpy of motion. And the second point is that thermal energy is required to overcome this barrier. So thermal energy, that is temperature, thermal energy is required to overcome this barrier, okay, to overcome this barrier. So we require temperature or thermal energy to overcome this barrier. According to the Maxwell-Boltzmann criteria, an atom may overcome this barrier when it possesses vibrational energy. Okay, the atoms, according to the Maxwell-Boltzmann criteria, when atoms may overcome this barrier when it possesses the vibrational energy, which is given as N, which is equal to, the vibrational energy is given as N, which is equal to Fe in bracket minus Hm upon RT. So what is N? N is nothing but your number of effective jump per unit time, and F is nothing but the frequency of vibration. Okay, so N is nothing but your number of effective jump, and F is nothing but your frequency of vibration, and this Hm is nothing but your the potential energy barrier. So this much energy, that is, according to the Maxwell-Boltzmann criteria, an atoms may overcome the barrier of parent atom when it possesses the vibrational energy, and this vibrational energy is given as N is equal to F in bracket minus hm upon rt. Okay, where n is nothing but the number of effective jump and f is nothing but the frequency of vibration. So this is all about the interstitial diffusion. So you should keep in mind whatever in interstitial mechanism, the small atoms which is present at one interstitial site get diffuses from one interstitial site to the another interstitial sites. Okay, so let's discuss the next one, that is the substitutional mechanism. The third one is substitutional substitutional mechanism. Substitutional mechanism. So first we discuss about the vacancy diffusion or vacancy mechanism, second that is interstitial, and then third that is substitution mechanism. This mechanism is also referred as vacancy interfacial mechanism. It is also known as vacancy interfacial mechanism. Interfacial mechanism. Vacancy interfacial mechanism. Vacancy mechanism in the basis of substitutional diffusion. Vacancy mechanism in the basis of substitutional diffusion. Diffusion proceed. So in this case, diffusion proceed. Diffusion proceeds when substitutional atom, when substitutional atom, substitutional atoms jump into substitutional atoms jump into a probable vacant site. A probable vacant site. Probable vacant site available in its surrounding. Probable vacant site available in surrounding. Probable vacant site available in its surrounding. That is, in this crystal there is a vacant site and the diffusion proceeds when substitutional atoms jump into probable vacant site available in surrounding. So if you consider this diagram, that is, again it is same like vacancy diffusion. Then this is the vacancy. Again here and this is like this. So again we already discussed about vacancy diffusion. It is nothing but the substitution. So vacancy gets substituted by the surrounded atoms. So this is all about the substitutional mechanism. The next one, that is direct interchange mechanism. That is the fourth one. Direct interchange mechanism. Direct interchange mechanism. So if you consider this direct interchange mechanism, so this is the diagram. So in this case there is a no vacant site is there. So whatever the solid does not containing any vacant site, but the two atoms, that is we can write this as, or the four atoms change their position. Two atoms, two atoms, three atoms, or four atoms change their position. That is, we can consider in this mechanism of diffusion the atoms interchange their position between themselves. So in direct interchange mechanism, direct interchange mechanism, the atom interchange their position, interchange their position, interchange their position between themselves. between themselves. So there is a no vacancy in this solid. So atoms, the adjacent atoms interchange their position. Two, three, or four atoms simultaneously change their position. So in direct interchange mechanism, atoms interchange their position between themselves. The mechanism may involve two atoms, three, or four, or more atoms interchange. The second point is that the mechanism may involve two atom, three atom, or or more atoms interchange. So two atoms, three atoms, or four atoms interchange. So in this case there is a no vacancy, you should keep in mind. In direct interchange mechanism, uh, directly the atoms which are adjacent to each other interchange their positions. Okay, so it is either 2, 3, or 4. 2, 3, or 4, so we can write this as, okay, so this goes here, this goes here, and this goes here, like this. Okay, 2, 3, or 4. So this is all about the mechanism of diffusion. So at least you should know the different types of uh, diffusion mechanism. One is vacancy diffusion, when there is a vacant site is there which create another vacant site. Then there is the interstitial mechanism, that is the atoms at interstitial site diffuse from one interstitial site to the another interstitial site. Then there is a substitution mechanism, again it is a type of vacancy diffusion. And the last one is a direct interchange mechanism, where the adjacent atoms interchange with each other with no vacancy in the material or in the solids. So this is all about the mechanism of diffusion. Whatever the remaining points we discuss in the next lecture. Thank you.